have seen. Okay, you can begin.
Okay. Uh, Hello everyone. I'm Wei Gao and I'm from the Institute of High Energy Physics of Chinese Academy since. It's an honor to give a presentation here, and I will give the report about the hybrid detection of cosmic rays within the ENDA-64 on behalf of the ENDA group. Sorry. Okay, my report contains four parts. First is a simple introduction for our physical motivation. As we know, the cosmic rays in the near range is a most interesting energy range for the cosmic ray spectral studies. It's a is a key tool for us to understand the cosmic ray acceleration and propagation mechanisms. But in such a high energy range, the detections are mainly relying on the extensive airshore arrays on the ground. So the measurements for the primary cosmic rays is based on the secondary particles for the it is based on the secondary particles to reconstruct the primary cosmic rays, such as its energy or the composition of it. So enter such high energy region around the knee. Its absence the device composition its emphasizes the individual composition cosmic ray spectrum measurements. So now the current the current observations has a tendency to mirror secondary to mirror the cosmic rays with multi-parameter observation, which can improve the precision for the reconstruction of the cosmic rays energy and its composition. So this is where the ENDA come in. ENDA is located in the lasso site, and our final physical motivation is to combine with the lasso and to mirror the to mirror the individual composition energy cosmic ray spectra. The second part is introduced for the end, and now, so this picture shows the lasso seat on the dot with an altitude of 4,400 meters. We deployed the we deployed the detectors or in the lasso site is in the direction of the southwest of the subarray or WCD, and this picture shows the end. Up to now, we deployed 64 detectors, and the detectors are divided into four clusters, and each clusters with each clusters with a trigger algorithm by itself. So the detectors has a space of about 45 meters uh, distance with each other, and the four coverage the the effective area of the array is about 1800 square meters. The purpose of the ENDA is to mirror the recital hadronic particles when the shore process arrived at the ground. So beside the Lasso's measurement for the muons and the electromagnetic particles, combined with the Indas measurement for the residual hadronics in the range of the core range, uh, we will uh, we will obtain primary cosmic rays message by the joint measurement for these two experiments. Now the four clusters using independent trigger mode. Now the trigger algorithm is two detectors must be faired at the same time. This figure shows a cluster. Shows the inventory range of one cluster is about 0.3 height. This figure shows the path height distribution of one detector. For example, so the spectrum contains three paths and the highest is from the noise, and the middle part, which follows on a parallel, is a signal. Is a single. This is this is the single thorough neutrals. And the much higher values is from the multi-neutrals. So we use a exponential function to fit it, and then the parameter of the B, it reflects the energy deposit by the thermal neutrals in the scintillator. We list the parameter of the four clusters in this table. We can see that the maximum coefficient of the variation is the cluster 2 is with a values about 6.8. And this table is for the event rate for monitor for the for clusters. Um, the maximum variation is little than 5%. So the array of the ENDA-64 is on a relatively stable operation. We select a cluster for to end the sand cubes under it to study the environmental influence for the neutral measurement. Just as the figure shows, on the top is our detector, and under it we deployed four sand cubes with the total volume of 4 cubic meters. And we collect the data. We collect the data from 2023 to ENDA-64 and divide it into three periods according the weather and the sand cube was deployed or not. The data was divided into three samples. One is collected in the rainy season and without the sand cube, and S2 is for the it is with the sand cube, but the data was collected in the dry season, and S3 is for the sand cube and with a rainy season. We compared the neutral measurement drawn these three pyramids. The results are shown in this figure. The bottom plot is make a ratio of the two data samples in the rainy season compared to the dry season. And with the lower events, the lower number of the nutrients is mainly from the background nutrients, and with the log n about 1.2 is from the EAS product nutrients. We also compared the uh, neutral measurement with a sand cube compared with the other three clusters. For the results of these two compare, we can make a conclusion is that the sand cubes can protect the detectors to reduce the effect of the uh, humidity, and the sand cubes and the sand cubes will enhance the detection efficiency of the nutrients at the same time. But we should note that the results are with a relative lower statistical accuracy. So we will go on our studies for it. This is a preliminary result for the nutrient spectra with about 18 months date. Um, we obtained the thermal nutrient spectra. This picture shows our working range is around the 3 PeV to 30 PeV, and uh, the lines in different color it refers the results are obtained from the data which have a different data selection. In a word, and the range of the log in from the 1.4 to the 2.5, and our working range is it is not affected by the data selection. That that reflects that in such area, the measurement is in the full efficiency. So even though with a lower stat, a statistic uh, accuracy, but our still observe the polar low spectra of the neutrinos, and with the index is about minus 2.1. So and such a accuracy we haven't we observed the spectra without any significant structure. Um, Another study is for the coincident events of the ENDA with chemistry. Um, this slide shows the experimental data. Um, So we select the coincident selection based on these two conditions. One is for a time window selection, and one is for the distance selection. Um, and the data, the reconstruction is a message is based on the CAM tree only. So this is a compare for the coincident events. So we have more than 95% coincident efficiency, and with the energy of the number of the electron number in the about 2.6, and this energy is corresponding to about 500 TeV. So with the coincident image, we compared the electron numbers obtained by the chem tree and ENDA, and also the muons from ENDA with the electron numbers of ENDA. So we can see the secondary particles. It follows on a linear relationship. While for the neutrinos it is not it is not along the linear relationship. Um, we also conduct a simulation for the coincident events. Uh, Here shows a event example. And this event is located in the ENDA, and then we compared two functions to fit the literal distribution of the electrons. One is the function is we use it is a modified NKG function. Here shows the lateral distribution of the electrons. The right point is from the ENDA near the core in the core ridge, and the blank ones is for the ED detectors or chemistry. Here we show the core resolution uh, uh, with the coincident events. And a high energy, and a high energy, the the joint measurement of the for the ENDA and the chemistry have a much higher accuracy for the core resolution. We also studied the lateral distribution of the similar neutrinos. And in this work, we use the NKG function and a two component exponential function to make a fit for the neutral distribution. This figure shows both the proton and iron sample. With a compare, we found that the double exponential function will provide a more accurate fit compared to the AKG function. And beside the lateral distribution fitting, We also find a parameter to uh, um, we also find a parameter for the filter's energy reconstruction and the composition separation. Here we make a comparison for the three parameters. Uh, uh,
Jarway, how
uh,
minutes you need else?
what?
What
Sorry.
time you need else?
Oh, okay. I will switch. Sorry. With our studies, uh, I'm sorry, I forgot this word. Um, so this um so with a comparing and the this value is more accuracy for the for the energy and the composition uh separation. Um, Finally, is a summary and outlook for our work. And no ENDA has deployed 64 detectors, and the array with a rate of 0.3 height. Um, Up to now, we have collected more than 1 year's data and is able to make some analysis. Uh, we contribute a Cube study to study the environment influence, and now we get a preliminary result for the neutral spectra. For the joint measurements with Chem2, we start the works both for the experiment data and for the simulation. And in the future, we will apply our literal distribution research to the data reconstruction and conduct physical analysis. That's all. Thanks.